Hey, better a day late than not at all. Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtual Weight, aka Mike Smith, and today we're going to be taking a look at the copy-within method of arrays. Now, copy-within allows you to take certain sections of an array and copy it to other sections of the array. It's supposed to be extremely efficient in that copying process. You want to see how it works? Let's get started. So copy-within is very easy to use. The idea here is that you'll take a range of elements within your array and copy it to another spot within the array. And this is the copy method right here. Basically, it takes three arguments. The first argument is the target, and this is the target index within the array, and this index must actually exist. In this case, I have an array of 9 elements, numbered 0 through 8, because remember, again, within JavaScript, indexes for arrays always start with the number 0. So cat is number 0, and lizard is number 8. So my target here is going to be 1, which means whatever I get to copy is going to start, or it's going to copy to index number 1. So it's going to copy into dog. The start is the beginning index number that that will be copying, that will be the source of the copy. And in this case, index number 0, the source of the copy will be cat. And the end is the index that the copying will end at, and it doesn't include this particular index. So for example, this basically says that I want to start at index number 0 and go to index number 1, but don't include index 1, which basically means I'm just going to do 0 and that's all. So what's going to happen here is that we're going to start with 0, we're going to end with 1, so all we're copying is just 0, and we're going to copy it to 1. So cat will get copied to dog. Now what will happen? Well, what will happen is that this is a straight copy. It will literally physically copy index number 0 to index number 1 and therefore mutate the array. So it's very important to understand this does not create a new array or anything like that. This mutates the array. So what I should expect with all of this is I should expect to see cat here and cat there and no more dog within my animal list. Well, let's find out. Let's see what happens. Let's go over to node and let's type in node copy within. And sure enough, that's exactly what happened. There's my original cat. Cat is now copied over to index number 1 because I said the target was index 1 and I wanted to copy index 0 up to, but do not include index 1. So it just copied cat. So let's start playing around with this. Let's go back over to our code here. So let's start now at number 1 again. We'll replace the dog, but this time I want to have an end of 5. Which means I want to include 0, 1, 2, 3, and 4, but not 5. So now I'm going to target to index 1, which is dog, but I'm going to copy cat, which is 0, dog, which is 1, horse, which is 2, cow, which is 3, and coyote, which is 4. So all of these will basically shift downward. I should expect cat to remain the same since I'm targeting number 1. This should be cat, but this should be dog, this should be horse, this should be cow, this should be coyote, and then dolphin will be the next one. So roadrunner should be the one that will be eliminated from this list because remember, it's just a straight copy overriding anything that's already there. Let's flip over to node, and let's just clear our screen off. Type copy within, and that's what's like that. This looks like that's what happened here. Here's cat, here's dog, here's horse, here's cow, here's coyote, and then dolphin, which means roadrunner got eliminated from our list. And so as you can tell there, that basically copied 0 through 5, not including 5, into index number 1. Now, like a lot of different operations, you can have negative numbers. What if I had a negative 2 here? And we'll eliminate the ending here for a minute. So what if I started with negative 2? And negative 2 basically says that, okay, I'm going to start counting from the end of the array. So in this particular case, I'm going to get the second element from the array, which is well. So I'm going to target number 1, and I'm going to get the second element from the end, which is well in this particular case. Now, I'm not specifying an end, and whenever you do not specify an end, that means it's going to take everything up to the very end of the array. So what I should expect here is I should expect whale and then lizard to be copied over to dog, because I'm starting with -2, which means 2 from the end, which is well, and I'm going to target to number 1. And since I have no end argument here, I should automatically get both whale and lizard. Let's check it out and find out. Let's go over to Node. Let's clear off our screen. Go to Node within, and whoa, that's exactly what happened. Here's my whale, there's my lizard. My dog has disappeared, but now I've got whale and I've got lizard. That means that both my dog and my horse has now disappeared. So if we flip back over to Node one more time, excuse me, my code one more time, we can also sit here and say, okay, I want you to now include ending at -1. So we're going to start at so we're going to start at whale here, and we're going to end and not include lizard. So now this should only copy whale. Let's flip back over to Node. Let's clear the screen off. And sure enough, yeah, only whale got copied. This time horse stayed there. Lizard did not get copied. So that's basically really all there is to the copy within. And again, it's extremely performance engineered to be as fast as possible to be able to copy, literally physically copy and overwrite one particular element or a group of elements into a target within the array itself. And again, the array is mutated. So what can it be used for? Well, that's a very good question. Let's take a look at that next. So what can copy within be used for? Well, I searched the internet far and wide, found a couple of examples, but nothing really caught my eye. The general consensus is, you know, nobody really knows what copy within can be used for. And now, obviously, they've programmed this thing for a particular reason, especially to be able to be very performant in doing the actual physical copying of one element to another or a group of elements to another. So there had to be some sort of reason it could be used. So I was thinking about it, you know, could it be used for sorting? Well, maybe, but the fact of the matter is that the sort method on the array probably works far better than anything that you might write in JavaScript, because obviously that's written like in C++ or C. I don't know what the heck JavaScript's written in the V8 engine, whatever. So I was thinking, well, you know, maybe if we were randomizing the array, since usually what you do with randomizing the array, you're moving elements around. Maybe that is what can be done. So I tried to write something here to randomize the array. Now, what I first did here is I got myself a routine that does a randomization of this particular array. Now, what I've done here is I just got, you know, 26 letters A through Z. And I, first of all, create an array by doing it in line 7 here, by doing a split on a blank string that will basically split every single element, every single character of the string. And so I end up with an array of 26 elements. Now this is the normal way that I will randomize an array, basically getting a random item between, in this case, of 0 and 25 index, and then I will splice that item out and then push it to the end of the array. And then by using index here within my randomization, my first randomized number will be between 0 and 25. My next one will be between 0 and 24. Next one 0 and 23, 0 and 22, and so on and so forth. So I don't randomize the same characters each and every single time. So this is the way I've always done random numbers. And this is an extremely fast way of doing it. So I got myself a little performance thing here to do 100,000 loops through to make sure, you know, to kind of get a good timing of how quick this is. So then, okay, what will this look like within using copy within? Well, basically it's pretty much the same idea here. First thing I'm doing is I'm increasing the length of the array by putting a blank element at the very end. And then by using this item right, copy within right here, I am now copying whatever item I found or whatever item I have randomized. I'm copying it to the very last item index, whatever that happens to be. In this case, last item index is always going to be 24. Yeah, 25, excuse me, I can't quite think. Yeah, which would be the length of the array minus 1. Actually, that should have been a constant there. That spelled right. That should be a constant right there because I'm not changing last item array. So this will basically copy whatever item I found straight to the very ending of the array, which is what I've got right here. And then when I splice out the original item, that will immediately get my length back down to the original length, and I will end up, and I'll just do again doing 25, 24. So this whole section here will basically copy the item to the end of the array, and then I splice out the original item. So this works exactly the same way. This is basically, for lack of a better term, this is a push. And then I splice here. So if everything is correct here, this should operate faster because I'm basically copying it from one section of the array to another, and then I'm splicing it. The only possible problem would be is that, since I got these on two separate lines, I don't know, that maybe it's going to be slightly less performant. I don't know. Let's find out. Again, I'm doing 100,000 of to find out what's going on here. So let's just go over to Node, and let's type in node random. And this will take about 1.5 seconds to 2 seconds. So our push splice randomizer read 100,000 randomized letters in 262 milliseconds. Our copy within splice one did it in 873. Try it again. Yeah, 266 and 893. We'll try it again. Yep, 272 and now 907. So it wasn't a whole lot different. I mean, so using the copy within here was actually less performant in this particular case, but doing the old method that I've done. And probably, I guarantee you, somebody's got there figured out a lot even more efficient method of how to randomize an array. So at least in this particular case, randomizing an array doesn't really quite work very well. So what's copy within used for? I don't really know. If you happen to know, make sure that you put something inside the comments. We'll test it out. I'll be more than happy to create a whole other video here just to test it out and see what we, if you get an idea there. We'll test it out and make sure it does work. Other than that, that's pretty much it. So again, I'm not sure what copy within can be used for. If you happen to know, pop something down in the comments. And that's all there is to the copy within method for arrays. I hope you enjoyed our video. Hope I didn't bore you to death. Please make sure you click on the like button below and subscribe to this channel for all future Boring JavaScript videos. Also, go to www.boringjavascript.com to see all the Boring JavaScript videos we've ever produced. Or you can go to www.thevirtualboy.com to see everything that we do. Thank you again for watching, and we'll see you later.